Von Fraassen begins by characterizing scientific realism along two dimensions. First, the aims of scientific theory construction, and second, theory acceptance. Von Fraassen argues that in general, we can understand, appreciate, and value scientific theorizing without being committed to scientific realism. He defends a non-realist view about science, and he describes this view against the foil of scientific realism. So what is scientific realism according to von Fraassen? For von Fraassen, scientific realists are committed to two main claims. First, scientific theory construction is aimed at finding a literally true description of the world. And second, an important part of accepting a scientific theory is believing that it is true. For example, a scientific realist, as depicted by von Fraassen, would say Darwin's theory of evolution is best understood as an attempt to find a literally true description of heredity. Similarly, Newton's theory of gravitation is best understood philosophically as an attempt to find a literally true description of gravity, and not just a model that helps us make accurate predictions. This way of thinking philosophically about science goes hand in hand with believing that when one accepts a scientific theory, one accepts it, at least in part, because one believes it is true. Von Fraassen will reject both of the claims he attributes to the scientific realist. For von Fraassen, there's a different way to think about scientific theorizing that does not require us philosophically to commit to the view that scientific theories are attempts to paint a literally true story of the world. Furthermore, for von Fraassen, accepting a scientific theory does not have to involve believing that it is literally true. We'll return to elaborate these aspects of von Fraassen's view shortly. But first, let's see how von Fraassen suggests we should understand the language of science. Scientific theories, like all theories, are expressed in language, and when we encounter language, we have to interpret it. So, how should we interpret the language of science? Let's start with a concrete example from Carl Anderson's famous paper from 1933, in which he announced his discovery of the positron, which is a subatomic particle with the same mass as an electron, but with a negative charge. Anderson posited the existence of the positron to explain previously unexplained tracks he noticed in photographic plates that were recording so-called cosmic rays. Anderson says, quote, "To date, out of a group of 1,300 photographs of cosmic ray tracks, 15 of these show positive particles penetrating the lead, none of which can be ascribed to particles with a mass as large as that of a proton, thus establishing the existence of positive particles of unit charge and of mass small compared to that of the proton. From the fact that positrons occur in groups associated with other tracks, it is concluded that they must be secondary particles ejected from an atomic nucleus." Unquote. So how should we interpret this bit of scientific language? Von Fraassen's answer is unequivocal. We should interpret the language of science literally. To interpret the language of science literally means that we do not have to use any special procedure to translate or decipher the meaning of a scientific statement. Von Fraassen points out that adopting a literal construal of the language of science amounts to a rejection of logical positivism. Here's why. For example, consider Anderson's claim that some tracks, quote, show positive particles penetrating the lead, unquote. For a logical positivist, the theoretical statement, "there are positive particles penetrating the lead," has its meaning exhaustively given through a correspondence rule that says something like this. There are positive particles penetrating the lead if and only if the photographic plate displays tracks of this specific kind. So for a logical positivist, when the theory says, quote, there are positive particles penetrating the lead, unquote, we should not interpret this sentence literally. Von Fraassen disagrees. According to von Fraassen, the theory simply says that there are positive particles penetrating the lead. There's no need to interpret that. We just read it at face value. If we interpret the language in Anderson's paper literally, as von Fraassen would have us do, we can conclude that Anderson's theory of the positron says at least the following statements. There are positive particles penetrating the lead. These positive particles, which we'll call positrons, are not protons. Positrons exist. Positrons have the same electric charge as an electron, but are positively charged, not negatively charged. Positrons are secondary particles ejected from atomic nuclei. This is what the theory of positrons says, according to von Fraassen. Notice that to insist on a literal construal of science is to take a stance regarding a semantic issue, namely, how should we interpret the language of science? However, for von Fraassen, it is an entirely different question to ask whether we should believe what the theory says. For this question is an epistemological question and not a semantic one. This is why, for von Fraassen, one can both insist on a literal construal of the language of science and be a scientific anti-realist. Von Fraassen says, quote, for this insistence relates not at all to our epistemic attitudes toward theories, nor to the aim we pursue in constructing theories, but only to the correct understanding of what the theory says, unquote. We have seen that for von Fraassen, a scientific realist believes that an important part of accepting a scientific theory is believing that it is true. According to scientific realists, believing that a theory is true is a necessary, though perhaps not a sufficient, condition for accepting a scientific theory. Von Fraassen rejects this view because von Fraassen believes that one can accept a scientific theory on grounds that are less onerous than believing that the theory is true. Von Fraassen articulates this clearly in his description of constructive empiricism. Quote, science aims to give us theories which are empirically adequate, and acceptance of a theory involves us belief only that it is empirically adequate, unquote. The first point von Fraassen makes in this quotation displays how we can think philosophically about science in a way that is different from that of scientific realists. We do not have to think of science as aiming to give us a literally true story of the world. We can understand, appreciate, and value science by thinking of it philosophically as merely aiming to give us an account of the world that is, as von Fraassen says, empirically adequate. This is not an epistemological claim, strictly speaking, but merely a claim about how we should understand the aims of the practice of science. The epistemological claim that underwrites von Fraassen's constructive empiricism is that with regard to the kind of beliefs that are involved when we choose to accept a scientific theory, we can understand philosophically that scientific theories are accepted merely because they are empirically adequate. Naturally, we can't make good sense of either of these claims without answering the obvious question. What does von Fraassen mean when he says that a theory is empirically adequate? Von Fraassen unequivocally states, quote, "A theory is empirically adequate exactly if what it says about the observable things and events in this world is true. Exactly if it saves the phenomena," unquote. This brings together everything we've seen from von Fraassen. Von Fraassen defends the observable versus unobservable distinction precisely because he wants to claim that we accept scientific theories because what they tell us about the observable world is true. What we should believe, furthermore, is nothing less but nothing more than what a theory says about the observable world. Here's how this philosophical approach to science would deal with Anderson's theory of the positron. Anderson's theory of the positron says that positrons exist and that they have certain characteristics. For example, they're positively charged and have a small mass. This is what the theory says. We accept Anderson's theory of the positron because when it says that we will see certain kinds of tracks on photographic plates, it gets those predictions about the observable world correct. However, for von Fraassen, we stop short of saying that it is literally true that positrons exist. Instead, for von Fraassen, we remain agnostic about the existence of the unobservable entities postulated by science.